I'm here with Philip from Incolor, and he's the engineer and the main brain behind all their frames. So I would like to ask him a couple of questions and whether he can guide us through their lineup. So yeah, Philip, could you please tell us a little bit more about the SR, SR Plus, your gravel bike, and also the concept SSR?
Yes.
All right, let's do this. So the SR and SR Plus, there is a different carbon layup, right?
Yes, the same model, but with a different carbon layup. The SR Plus have a T1100 the carbon layups, and the lower one have a T800. Yeah.
I see.
And the weight difference is about 60 grams between those two frames.
60 grams?
Yes.
Okay, so that's not too significant, I would say, but the ride quality should be even better on the SR Plus, or?
Yes. That will be feeling lighter and maybe agile than the heavier one. But the feeling quality, the riding quality is almost identical to each other.
I see. And what about the compliance? Is the higher end frame even more comfortable than the previous one?
No, it's the same.
Same comfort. So maybe just a little bit lower weight and increased stiffness, maybe.
Yes. But and with some 3D printed titanium parts on the higher frame.
I see. And by the way, how long did it take you to design this frame, and how long does it take from the initial idea to the production bike?
It takes about 3 to 4 months for us to design a bike to make it looking better and have the engineering performance. Mm-hmm. And we will take another half year to development the bike in the factory and in the wind tunnel to get it have a aerodynamic performance to improve to meet the highest standard. And it will take about 1 year for us to complete a new bike design.
I see. So you first prove your idea via CFD modeling, right? And then once you have, let's say, the last, 5 shapes of the frame, then you start testing them as well, or?
Yes. It will take several models for us to improve the bike. But with our company development, we have used more and more times on the CFD and more and more computational power to do the CFD. With the SR model, it takes about 2 or 3 months to do the CFD procedure. But when we do the SSR, it will take about half a year. And when we come to the TTR, our newest time trial bike, it takes our more than 1 year to test about 50 different models to get the best result.
Yeah, so we can see some of the models of the TT bike here, right? On the display.
Yes.
You tested over 50 different iterations,
yes.
Right?
There's only half our iteration showing here. Actually, we have double of this amount of models we have tested in the CFD.
Yeah, that's great. We will talk about the TT one in a second, but maybe we could also talk about your gravel model. So let's go there. So this is the Voyager, and you basically took everything what you learned from the SR and applied it here. Or was it completely different process? Had you have to design the frame from scratch?
Yeah, this frame has the same design language as our road bike model, but they have a larger tire clearance, like the 45 millimeters tire clearance. But I also want this bike not only work as a gravel bike, but it's more like a all-around road bike, but with a bigger tire clearance to ride on. So you could actually put a road bike wheels on that to just make it like a normal gravel bike or all-around road bike. But actually, you could fit the gravel tire to have a light gravel riding. But I think to the Western people, this gravel bike will be too light because they want the gravel bike to have a longer front center and a bigger tire clearance. But I think they will very much like entrance bicycle for amateurs to ride on, not only at on the gravel roads, but also on the tarmac roads to have a road bike for all the road you need to ride on.
Yeah.
So with only one bike.
I see. So do you eventually plan to release a new gravel bike that will have even wider tire clearance that will be more suitable for more hardcore gravel racers?
Yes. We actually plan on to do that in the future with a longer front center and higher, bigger tire clearance, and maybe some soft suspensions on that.
Okay, I think that will be great because many people criticize when a gravel bike has a tire clearance of only 45 millimeters because they want to put massive tires inside and they are not able to do that with 45 millimeters.
Yes.
So.
In China, we consider this as a gravel bike, but maybe to the Western people, this is more like a all-round road bike or endurance road bike model.
Yeah, exactly.
Yeah. But the riding quality is more like a road bike model because the rear center is only 450 millimeters long, so it's more like a road bike feeling. And you could also put on a front derailleur on that, so it's more like you could put some road proof set on that.
Yeah. So this is funny because they have this super bike here with flat pedals, but obviously we are at a bike expo, so there is no sense in having clip-in pedals. But yeah, this one created waves in the industry, right?
Yeah.
Because it's super aero, super thin head tube, super thin seat post, but also super lightweight. So how did you even achieve something like this?
So in our brand's concept, we want to have a best aerodynamic performance, not only by make the tube to be very long, very high aspect ratio, but we want to cut down the frontal area of the bike.
Yeah.
So you could see the frontal area of this bike is extra small.
Yes.
You have a 34 millimeters wide head tube, so you could cut down the A of the CDA. There were two formulas. One is the coefficient of the drag, and the other one is the area of the frontal side. You have a area, so the multiply will be the total drag of the bike. So you could either minimize the coefficient of drag, or you could minimize the area. So we are focused on minimize the area of the frame. So you could get a frame have a low air drag, but also you could have the frame have a minimum surface area. That leads to we could reduce the carbon fiber we use in total for this frame. So you could have both aerodynamic performance and have a very light frame.
I see. Yeah, that's great. I mean, we probably won't dive too much into the technicalities of the physics and everything because I'm not proficient in that. But yeah, you also pair the frame with aero bottles, right? Because it would be pointless having rounded bottles because those would increase the drag around the bike, right?
Yes.
So then you design these aero ones.
So when we finish our design of our bike, we find there were no bottles in the market can have the same width of our bicycle, our dome tube. So we have to make our own bottles for exactly this frame to fix the width of the down tube to have a 45 millimeters with very thin bottles to have improve the aerodynamic performance of this bike.
Yeah.
So it will save about approximately 5 to 8 watts compared to traditional round bottles you get from that, and it will even performance better than other brands air bottle because their bottles actually have a higher width.
I see. I mean, 5 to 8 watts just because of different bottles. That's a lot.
Yes,
that's a lot.
That's normally much get than one bike frame compared to another bike frame.
Yeah. One thing that struck me is that you still use flat handlebar.
Yes.
And the trend seems to be that many brands started to introduce raised handlebar. Do you also plan releasing raised handlebar, or do you think the geometry of the frame is good enough for flat handlebar?
Yes, I think it's always good for users. They could use other brands handlebar that fits their needs. They might need to have a traditional handlebar, some separate stem and handlebars that could fit their own needs. So we are insist on using the traditional design of handlebars to meet the customer's need. But on the other hand, I have ride road bike for about 10 to 12 years. So my point of view, I want to keep the bike looks as the classic road bike looking, and that's my prefer of the bike shape. So I rather kept this shape of the handlebars.
And maybe two last things that I would like to talk about with you are the details. So you are using 3D printed titanium by computer holder and other details. That was a decision just because of the luxuriness of this frame, or also because of weight savings, or?
No, the titanium parts, we actually can get a very high stiffness to weight ratio you could get from the 3D printed parts. With the original aluminum part, takes about 30 grams to make a strong enough computer mark. But with the 3D printed, you could get about 10 to 12 grams lower from that. You could get the same strength from that. So that's the decision behind our design. So we make the frame as light as possible, but have the same strength as other design, other traditional design.
I see. That's great. I mean, marginal gains everywhere, right?
Yeah.
All right, and the last thing I wanted to talk about is the integrated seat post.
Yes.
So why did you decide to have an integrated one and not a standard one?
When we designed the SR model, we found out that if your seat tube is very thin, that when you fit the seat tube inside the frame, that will still get some flexible around the seat tube, and you can't fix that because there always a fixed point in the frame. There will be always get some flexible from the seat post. That won't be enough for riders that have a heavy weight. But when you use an ISP seat post, the flexible around the seat tube is eliminated from that, and you could get a very comfort riding performance when come to the horizontal. But you still get the seat tube as vertical stiffness is enough for riders. On the other hand, the ISP is more aerodynamic, and the frame weight is reduced by that.
Yeah.
So you could eliminate the weight of the and one seat post.
I see. But on the other hand, the customizability of the frame is much worse, because once you cut it too short, then you are basically screwed, because you can't extend it.
Some trade-off inside that. So of course, riders could use some different heights of the installation plate. So we have a different heights of that to adjust the seat height a little bit.
That's good.
So this is a.
So instead of moving the seat post, you basically move the saddle by using different pads, or
still have adjustable ability for people to have a different seat height.
That's smart.
Yeah.
But I would still recommend people to measure twice before cutting the
Yes, of course. The higher end road bike needs to make the installation very careful for that.
Yeah.
I think there will be some trade-off when you come to performance and benefit for people to do that.
Yeah. And what about the aerodynamic testing? Do you have any data that you could share with us? And ideally, can you compare the aerodynamic data of this frame, for example, with the Colnago Y1 RS or other high-end frames?
Yes. We actually put this bike with a several S5 in Silverstone winter note to test it, and the data is slightly better than the S5, about 1.8 watt average angles to better than the S5. So it's not a very big gap, but I think that's because the S5 is at a very high aero performance, so it's with this lightweight frame, but the aero performance is as much as a very pure aero bike.
And do you think you can push it even further? Do you think you can achieve even better numbers?
Maybe we could put some design language from the time trial bike to have even aggressive aero design in the future. Maybe 2 or 3 years later, and the next generation of the SSR, maybe.
Yeah, I'm looking forward to it, man. This one is really impressive, and maybe I will try it outside today because you have the flat pedals there. So yeah, maybe we can move on that TT bike then.
Okay.
This is the TTR. It's your concept TT bike, right? This one is not a final production bike yet.
Yes. It's not only a concept, but we are hoping to mass production this bike at the end of this year.
At the end of this year, awesome. I mean, it's a beautiful bike, and over there we can see multiple iterations you've done. How long did it take you to get the idea and to get to this point?
Yeah, we takes about more than 1 year to complete the CFD process we do on this bike to get about 18 watts from the beginning to the
18
end.
watts?
Yeah.
You saved 18 watts. Wow.
Compared to the first model we saved it.
That's a huge saving, especially
in
TT, right? I don't know where to start, so maybe the fork, like why do we have this shaped fork?
You could see the wave shape around the fork. It's actually reduce the bigger vortex generated by the side wind when you come with a side wind from the front.
The vortexes.
Yeah. The surface will generate some big vortex from the surface, so you will increase your jet. So this wave pattern could cut the vortex into small pieces. Yeah. So you could attach the airflow around the fork. So you could reduce the jet around the yaw angle about 5 to 12.5 degrees. The jet will be lower at this specific angles of yaw angle. Vortex
doesn't mean that you have like a turbulence behind the part, and that creates drag. Am I right?
Yeah. There will be a low pressure area generated by the vortex. It will increase your drag.
Yeah.
So the main focus of reduce a bike drag is to reduce the vortex strength.
All right. Then you also have a cover of your chain rings here. So this will be a part of the final production bike as well, right?
The cover will be individually products to fit a specific crankshaft and a chain ring. But it all comes to the finish with the crankshaft, because you need to make the gap very small to have enough air performance.
Yeah. And maybe I forgot to ask you one thing. So you decided to use this wide fork, and also you have really wide seat stays. So why is that? Why don't you have, for example, much narrower fork or narrower seat stays? Is it because of the flow of the wind around the bike, or?
So on this bike, we want to explore the strong coping effect between the rider and the bike. So we have the front fork and the seat stays stay exactly on the front side and the back side of the rider's thighs and the legs. So you could minimize the jerk generated by the fork and the seat stay.
Yeah, I see. So basically, when the wind hits it from the front, it spreads the air around your leg and thigh.
Shields your sides. We also have some small slots at the front of the seat stay to reduce the vortex strength behind your thighs.
I guess this will be a triathlon bike, and it won't be UCI legal because they have very strict design regulations, right?
Yes, I think this bike could meet the UCI legal the regulation, but when we come to the UCI aspect, we need to discuss with them to see if the bike is completely meets the UCI regulation. But we have our confidence on that.
Ah, I see. And maybe the last interesting part is this gap in the seat post. So why is that? Why there is a gap like that?
Actually, it's the same reason we as the seat stay. You could hide the seat post behind your side. Yes.
Yeah. Okay.
It's just the same reason as the seat stay and the fork.
All right. So maybe we can try it out.
Yes.
Let's do it.
Of course.
I mean, I would need 1 or 2 kilometers straight and just push it hard, but I'm still kind of scared because I don't want to crash or something, but
it feels promising, maybe.
Oh yeah, of course. I would really like to try it like full gas.
Yeah.
That would be terrific, but
the bar width is aggressive now and maybe low and maybe narrow.
Yeah, but it's too narrow for going out of the saddle almost.
Yeah. But it also meets the UCI lowest width of the handlebar.
I mean, beautiful work. Thank you so much, Philip, for walking us through your lineup.
Yeah.
Maybe I will also take the SSR just for a quick spin here.
Yeah.
But yeah, it's a beautiful machine, and I'm looking forward to see more from your kitchen.
Yeah. Thank you.
Thank you as well.